Hello everyone, we continue with another lecture on the topic of composition of functions. I want to show you a couple of examples, and they're interesting examples because they generate a misconception actually. So f of x and g of x are both reciprocal functions. One is 4 over x, one is 3 over x, and we are going to find f or g of x, a very simple question. So we're going to say this is f of g of x. So that will be f of 3 over x, okay? And then f of 3 over x would be 4 divided by 3 over x. And that would be simplified as 4/3 times x, which is a linear function. So if somebody asks you what is the domain of f or g of x, most likely you're going to say the domain is a set of real numbers because 4/3 of x is a linear function, and a linear function has a domain of set of real numbers. That's what you probably would say. So you're going to say domain of f or g is the set of real numbers. So that's what you're going to say, all right? Now, I want to show you that this is completely incorrect. I want to say that this is wrong, actually. Now, you may say we didn't do anything wrong here. You're right, but you'll see what happens shortly. We said that domain of f or g of x is the set of numbers like x belonging to the set of domain of g, such that g of x belongs to the domain of f. And you can visualize this in this diagram. It's not the first time we talk about this. If you have x as an element of domain of g, then that x is mapped onto g of x, or let's call it y, this so-called output number, by the means of this function g of x, okay? So we have domain of g, we have range of g, both in blue, and function g of x maps x onto y. X is the input number, it belongs to the domain of g, and y is the output number. And then what the second function f does, it grabs the output number of the first function g, which is y, or g of x, and maps that onto f of g of x, okay, on its own range. So this red circle here represents the domain of f, and then the other red circle is the range of f. So basically what f does, it maps y onto f of y, let's say. So the output values for g, which is y, are actually the input values for f, okay? And in order for that output number to be defined, x must belong to domain of g. And that's why here we're saying that x must belong to domain of g such that g of x belongs to domain of f. And that's what we have to follow here. So I'm going to say domain of g here is clearly all real numbers except x cannot equal to 0. And here domain of f is going to be all real numbers. Again, it cannot equal to 0. So when we say that, if we follow the formula, we're going to say x belongs to domain of g, which means that x cannot equal to 0, clearly, such that g of x, which is 3 over x, it has to belong to domain of f. And what was domain of f? We said the domain of f is all real numbers except 0. So that means that 3 over x cannot equal to 0. Okay, so we know that 3 over x will never ever be equal to 0 anyway, because its numerator is 3, it's never equal to 0, no matter what value you select for x. So that condition, the fact that 3 over x is not equal to 0, is automatically satisfied, okay? It's just stating the obvious. So here we're going to say x belongs to the set of real numbers, but x cannot equal to 0, okay? If I want to write this in interval notation, it would be negative infinity up to 0, excluding 0, union of that interval with 0 to positive infinity, all right? So now this is not matching with what we had before. So that's what I wanted to show you, that if you just blindly and directly calculate f or g of x and find its domain, sometimes that domain is not a correct domain because you don't take into account the fact that x must belong to the domain of g. In other words, x cannot equal to 0. Therefore, this answer here is the correct answer, and this one here we got is actually incorrect. So you should always be very careful and not blindly and quickly rush in calculating f or g of x on whatever function you saw, you find the domain of that function. There's a conflict of domains here. Clearly you see this is the actual domain. And all of this is initiating from the fact that x must belong to domain of G, because this G of x is defined only when x belongs to domain of G, and that has to be taken into account. And what was domain of G? Domain of G was telling us that x cannot equal to 0. So we had to take that into account. We didn't. So that was an incorrect answer, and this is the correct answer. This is another example here. F of G of x, if I calculate it, it's going to be f of G of x clearly. So that will be f of 3 times the square root function. And that will be 3 times square root of x minus 2, substituting for x, minus 2, the whole thing squared. If I square this, I'm going to get 9 times x minus 2 plus 4 minus 12 times square root of x minus 2. If you simplify, you get 9x. 2 times 9 is 18. So negative 18 plus 4, it's negative 14 minus 12 times the square root. Okay, so this is what f of G of x is actually. Now, when you look at this function, you say, okay, 9x minus 14 is just a linear function, and that is defined like everywhere, except the radical has to be defined when x is greater than or equal to 2. So you're going to say most likely that the domain of this function is actually values of x such that x minus 2 is greater than or equal to 2. Greater than or equal to 0. So that means that 2 comma positive infinity, that closed interval will be the domain of f of G. This is what we obtain, of course. But what is the truth of the matter? We have to check out. It says domain of f of G is numbers like x belonging to domain of G, which means that x has to be greater than or equal to 2. And of course, it's a real number. So that is the first part. But then it says G of x belongs to domain of f. But what is G of x? G of x is 3 times square root of x minus 2, which has to belong to domain of f. And domain of f is, of course, the set of real numbers. Everybody knows that domain of quadratic function is the set of real numbers. So when we say this expression, G of x, must belong to domain of f, it means that this has to be actually a real number. And I think it is very clear that it is a real number. So if I rewrite this here, 3 times the radical, I'm saying this has to be an element of real numbers, and that is automatically satisfied, because a square root function is a positive function. 3 times that is positive, and a positive value obviously belongs to the set of real numbers. So that condition is automatically satisfied. And now we can say that the domain of f of G is x greater than or equal to 2. And of course, x has to be a real number. So we see that in this case, the domain is the same actually. If you would say the domain here is actually domain of f of G is x greater than, let me use the interval notation here. If you would say x is greater than 2 and it goes up to positive infinity, this would be the same domain that we found here. So in this case, we didn't have any sort of conflict of domains. Okay. Another example I can give you. Well, we can have, let me do this question first, and then if there was time, I'll do another one. This question has nothing to do with domain. It's just an extra exercise. F of G of x is given as a linear function, 2x plus 1. F of x is 4x minus 3. That's another linear function. We want to find the function G of x, sort of working backwards. So we're going to say f of G of x, first of all, is f of G of x, right? So we know that 2x plus 1 should equal to f of this G of x, right? But the thing is that what is f of x? It's 4 times x minus 3. So 4 times this G of x minus 3 is what f of G of x will be in reality. So if this is equal to 2x plus 1, you can easily solve for G of x. You say 2x plus 1 plus 3 equals 4 times G of x, and from there, G of x will easily be found. That will be 2x plus 4 all divided by 4, which gives you x over 2 plus 1. So the unknown function g of x was eventually found by simple algebra. It was just an extra exercise I wanted to do. But these two questions, they showed us conflict of domains. In this case, of course, we saw that it was matching. So if you would find f of g of x, which is this function, and you would find the domain of this, you would say it's positive values more than 2, including 2. That would match with the domain that we find from the definition. In this case, we noticed that it didn't match. So in general, we just have to be very careful. Sometimes they match, sometimes they don't. We have to be very careful. I'll give you another example here where we have a conflict of domain. Now maybe I can erase this part and I'll show you this exercise here. Again, I want to show you that there is a conflict of domains happening, and you have to be very careful. So g of x this time is 3 root x minus 2, and f of x is x plus 2 all squared. Clearly, domain of this function is the set of real numbers. It's a quadratic function, and clearly domain of square root function is going to be always the positive values of x, including 0. So here, if you find f of g of x, again, in a rush, let's say, it would be f of g of x, right? And then that would be 3 root x minus 2 plus 2 all squared. And that gives you 3 root x all squared, which is actually 9x. Once again, you're going to say, well, this is a linear function. So domain of a linear function like 9x is the set of real numbers. So by mistake, you're going to say domain of f of g is actually the set of real numbers. Okay? I'm going to show you that this is incorrect. Now, if you would follow the definitions that we have, okay, if you follow the definitions, you would say domain of f of g is actually, you would say x belongs to domain of g, which means that x has to be positive, and any real number that is positive and is 0 or 0 is considered okay. But g of x belongs to domain of f, which means that g of x was this function. So I don't have room here. I'll write it here. It's 3 times root x minus 2. This expression had to belong to domain of f, which is actually the set of real numbers. Okay? So here, it is very clear that whatever x you select, 3 times square root of that x minus 2 would be a real number. So this expression belongs to the set of real numbers. That is automatically satisfied. We don't argue. But then here we have x greater than or equal to 0, and x has to be any real number. In other words, it starts from 0 and it goes towards positive infinity. That is the correct domain of f of g. But see what we got before. We got an incorrect answer, which is not matching. Here we're saying that negative numbers are okay. Here we concluded that negative numbers are not okay. So this answer here is incorrect because we didn't take into account the fact that x should belong to domain of g, as I explained in the diagram. But this answer here is actually the correct domain of f of g of x. Okay, so again, we have a conflict here. We have to be always careful and not just blindly and quickly rush in finding f of g and whatever function we saw, like here 9x, and you say, okay, domain is set of real numbers. No, we have to always bear in mind that x must belong to domain of g of x. This is the second example I showed you about the conflict of domains. In this case, we didn't have conflict of domain, but we double-checked, everything was fine. So sometimes we do have conflict, sometimes we don't. So you have to always and always follow the definition that has been explained several times in the past. Okay, I hope you understood how we find the domain of the composite function, and I hope you are going to watch these video lectures multiple times. This is extremely important because if you think you're going to watch these video lectures once and you're going to get everything, you are absolutely wrong. You have to watch them twice, 3 times, 4 times. First time you watch, you get some of the ideas. Second time you watch, you start understanding better. Third time you watch, you start, paying attention to the details. So it is extremely important to watch them multiple times. and you can pause them, you can rewind them, watch them again. And that's the advantage actually of these video lectures, that you have 24/7 access to them, first of all. Second of all, you can watch them as many times as you want. You have to take notes, and hopefully by doing all these things you will learn about the composite function. Okay, thank you very much, and keep practicing.